Hello. In the last lesson, we've laid out our texture actions. All that is left now is to load the texture, transfer it into the GPU by making it an image, and finally creating a descriptor set for the uniform sampler. We'll start by taking a header file for loading images. It is a part of this STB library. I get the STB image header here, and I copy the raw code from it. I then go into the project and create a file with that name. Inside, I'll paste the code that I copied. Now, if you take the time to read the documentation, you will see that we have to have one file where we define STB image implementation before including this header. So I quickly create a new CPP file, and inside it I add this definition and then include the header file. Now I run cmake to get the changes, and I go to the graphics CPP file. Here in the create texture sampler, we will start by reading the file. We already have this read file function from the shaders video. So I read the image into a vector of bytes. Next, we would like the STB library to process our data into an image data prepared for use in Vulkan. We want to do this since most images are compressed, and the STB library will uncompress those values into red, green, and blue channel format of pixel data. To do this, of course, I have to include the header file that we added. And I use stbi load from memory, and I pass in the data pointer and the data size. We also want stbi to initialize some additional data from our image file. And this will be the size of the image on width and height, and also the channel count. So we get the width into the address of x and the height into the address of y. The channel count into the channel's variable address. And we will set the value that we prefer to have for channel image in the end by setting the last parameter to RGB alpha. Now, somewhere after that, we'll need to call stbi image free with this pixel data. Between this load and free, we'll move the data into a buffer. So we create a new buffer that will be staged for moving into the GPU. The buffer size will be the image on width by the image on height by 4 channels that we requested. The buffer will be created with this size, and it will be used only for transferring this data into an image later. So I set the transfer source bit. It will be host visible and host coherent. Before we return from this function, we will destroy the staging buffer. And in between, we still need to copy the pixel data. So I get the data location by calling the vk map memory. And we've done this before. We need to also call the unmap memory after that. And in between, we can use the memcopy to copy the pixel data into the data location. This is pretty much it. We now have the data prepared for being uploaded to the GPU as an image.